Oop, there we go. All right, this is the tutorial for the checkpoint 15 in Algebra 2A. We're going to be going through and reading some graphs and determining what characteristics from a list fit this graph. So let's first just look at what this first graph is. Here I have a kind of an upside down W looking shape, which means that I'm going to have two x-intercepts. I'm going to have a minimum value right here at that negative 9.4. Because I have this W shape, I have some increasing, some decreasing, increasing, and then decreasing again. And then I'm also noting that the end behaviors are going both towards the negative on both the left and the right. So that's just a quick glance at that. So let's just look at the mathematical wording to see which ones fit this. So here it's talking about the x-intercepts. So the x-intercepts, we have two, as that -1 and 2.5. But see how these, oh, that was tricky. See how those are coordinates are flip-flopped? They aren't matching where the actual coordinates are. So it's not going to be this one. So let's see what else it could be. It says the zeros of the function are -1 and 2.5. Zeros are another name for x-intercept, so that is actually true. And then it also says the zero of the function is y. Nope, because zeros are another name for x-intercept, so it would never be a y equals. I just wanted to make sure I had my values correct. -1 and 2.5, that is correct. And then here we have the x-intercepts at -1, 0, 2.5, and 0. Yep, so that matches up with what we've identified as my zeros. And the y-intercept is at 0, -6.3. Let's just double check. 0, -6.3. Yep, that makes sense. Okay, so now it has something about the domain of the function. So domain is what x values are true or that are working in this for this graph. So I can very clearly see specific x values, like the value of -1 is on the graph, the value of 2.5 is on the graph, but we also have like other coordinates. This coordinate over here that is represented by like maybe, I don't know, 3.5, that is also on the graph, so it's working for the graph. In fact, all of this line is represented of every single coordinate point between them, and then these arrows indicate going on and on and on forever. So since there's no holes anywhere, this graph doesn't stop anywhere, we know that the domain of the function is all real numbers. There's no x value that didn't work in here. And then let's look at the range. The range is talking about the y values. And this is a possibility from -infinity to 0. So y values, does this graph go on and on and on forever down to -infinity? Yep, I can see that because of the arrows. And then does it have a maximum of 0? Yep, here's my maximum values. And they're on the x-axis, which means they're a maximum of 0. So that's question 1. We're going to click next. Moving to question 2. So now I have some kind of a, I would guess maybe a quartic, but you don't need to know that. But I do have end behaviors of up and up. I have a down, so decreasing, and then an increasing. I have a minimum value at -1 and 0. That is also going to be the x-intercept. And I have the identified y-intercept. Okay. So the domain of the function is -infinity to infinity. So do every x work? Yep, this line, the fact that it's continuous, there's no holes, there's no jumps, but the fact that it goes arrows both directions to the left and to the right, it means that it's all real numbers. And the range, does it start at 0 and then go up from there towards infinity? So the range is the y value. So the y value starts at 0 and then does it go up? Yep. Now we can see the x-intercept is at 0, -1. Nope, that's not it. They're flipping those coordinate values on us just to trick us. But this one is true, which means that we do not have a 0 because zeros are not y values. We've already discussed the domain, but we do have a 0 at x equaling -1. That makes sense. Okay, so that's question 2. Question 3. All right, lots of different coordinate points in here, so let's just kind of keep that in our mind. But we do have end behaviors of up and up. We have something coming down, decreasing and increasing, decreasing, increasing, lots of x-intercepts, a maximum value, a minimum value, lots of information to pull from that graph. So first it says the zeros are x equaling -2, yep. X equaling 1, yep. 2.5 and 4, yep, those make sense. So then can we take the zeros and rewrite them as coordinate points to be -2, 0. The 1 is written as 1, 0. The 2.5 is written as 2, 0. And then 4, 0 would be my last x-intercept. And then the y-intercept, I can see that here to be 0, -20. Yep. Which means that flipping these coordinates would definitely not make for x-intercepts. Okay, the domain of the function is -infinity to infinity. So is this saying, does every x value work? Yep, I can see all those x values in there. And then the range, it starts at -35 and goes up from there. So -35, yep, that's the very bottom of the graph. But then my graph goes up, there's no holes, there's no jumps, so it's going to be continuous from there. So that makes sense. We've already discussed the domain, so it's not going to be that guy, and a 0 cannot be y's. Beautiful. All right, this is going to be the last question that I'll do for you here. Which function rule does this graph represent? So this is now taking the rules that we know about how to find these x-intercepts and then kind of working backwards. So can we take those x-intercepts and rewrite them within the rule? So I just want to give you an example of what it is that I'm talking about. If I have a quadratic function, sorry, my pencil is so big, of x minus 3 and x plus 2.7. And I said 7, but I wrote 6. Remember that we would solve this by pulling the two factors apart and saying now x is not equal. X minus 3. X minus 3 is now equal to 0. And then x plus 2.6 is equal to 0. So this would mean x is now equal to 3 and x is now equal to -2.6. So what this is asking, can we find the x-intercepts from the graph and then work backwards to rewrite them as the factors? I think we can. So let's look at the first x-intercept. It's going to be at -2. So I'm looking for a factor to be x plus 2. So -2, 0 turns into a factor of x plus 2. And then I have another x-intercept right here would be at 1, 0. That would turn into a factor of x minus 1. And then I have another x-intercept of 2.5, 0. That turns into a factor of x minus 2.5. And then last one is 4, 0. That turns into a factor of x minus 4. So now I just need to find which one of these matches all of those factors. It's not this one because you see that x guy out there? Nope, 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 nope. Now they could be in flip-flopped order. So instead, this one has an x plus 1. Nope, I need an x minus 1. And then I have it multiplying with x plus 2, multiplying with an x minus 4, and then that last one of x minus 2. There it is. So I hope that at least gets you started on the first 4 questions within this checkpoint. If you need help with anything else, please do reach out.